Okay, let's get cracking. So, hello and welcome to today's webinar. Thank you very much for joining us. My name is Stuart Scott. I'm the AWS and Security Content Lead here at Cloud Academy. And today we're going to be focusing on and be looking at AWS cost optimization and ways on how to get those pricing models right for your infrastructure. Now, understanding these different cost models can become a little overwhelming and confusing, especially if you're not familiar with the benefits of each of the different approaches. And sometimes this can lead to unnecessary costs through that lack of knowledge. So hopefully by the end of this webinar, we can help you to clear up some of those questions relating to cost optimization to help you implement your solutions in a more cost-effective manner. Now, on the panel with me here today, we have the pleasure of Kevin McGrath, the CTO of Spot by NetApp. So welcome to you, Kevin. Thank you very much for joining me today. How are you and where are you calling in from today?
Hello, Stuart. Glad to be here. Calling in from right outside Washington, D.C., actually. I'm on the Maryland side of the Beltway here on the East Coast of the United States.
Nice, nice. Quite a distance from myself then in the UK.
So we got a little bit of water between us.
So I'm excited to hear what you have to discuss with us today, just to try and help us all run our infrastructure in a more cost-efficient way and preventing us from burning a hole in our pockets. Now, before I hand over to you, Kevin, to give us the agenda, I just want to let everyone know that this webinar is being recorded, and so you will all receive a link to it as soon as it's being published. And also, if you have any questions throughout the presentation that Kevin's going to be running, then please use the chat window. We'll get to as many of them as possible during the Q&A at the end. So let's get straight into it, and over to you, Kevin.
All right, thank you very much. And just want to thank Cloud Academy again. Always been a great partner to do these webinars, and hopefully, we have a lot of good content to share. So I'll get right into it. Yeah, thank you. And we're going to jump right into it. We're going to talk a little bit about cloud economics, high level, get everyone baseline on what cloud economics is, where you need to focus. We're going to talk about the Spot by NetApp platform, but while we talk about the platform, we're going to talk about why the platform does what it does. So understand why the platform looks to optimize costs in the way that we do, so you can take that and look at your own platforms and make a decision on how to be as cost effective as you can be in the cloud. And then lastly, we're going to do a quick product overview. It's not going to go too deep, but we're going to highlight one of our products called Ocean, Kubernetes offering, and then we'll jump right into a Q&A. So let's get into it. Cloud economics. So what are cloud economics? It means a lot of things. Years ago, it was basically, how much on-demand compute am I running in the cloud? Am I running more? Am I running less? But the cloud has gotten pretty complex. So there's a lot of things that go into cloud economics today. So the big picture is, what does that actually mean? Is it just the things I'm running in the cloud? Is it how I'm running the things in the cloud? Is it how efficient an application runs in the cloud? Or is it how efficient is the infrastructure that supports that infrastructure or that application, in the cloud? So there's a lot of things that go into the whole cloud economics picture, because every API you hit, every little thing you touch along the way on a cloud API can have a dollar sign associated with it. So how do you know when the dollar signs are going up and when they're going down?
And I think, Kevin, just to jump in there, some people kind of aren't aware of where all of these costs come into sometimes, and get quite a surprise sometimes when they see that bill come at the end of the month that they're being charged for certain elements. So you really do need an understanding of the broad spectrum of where those costs are coming from.
Yeah, I do think sticker shock is a big thing for some people sometimes. Sometimes they don't realize what they've turned on, what it's going to cost them because of downstream services. And sometimes it's just that they don't know someone on their team left something running. So it can come in all forms and shapes and sizes. And that's a really good segue into, what are hard savings and what are soft savings. And I'm not necessarily going to read every single one of these bullets word for word, but hard savings are things that, things that maybe you used to be able to touch in a data center, or things that you can, instantly turn on and off. They have on and off buttons. So it's, I can turn off a certain number of instances, or I can avoid sending my network traffic over a certain availability zone or a certain path that's going to cost me more, or I can reduce costs by keeping my staging and dev environment smaller than my production environment. So there's very hard things that you can do. And then there's soft savings. And soft savings is a little bit different. Soft savings is, how can I reuse services? How can I maybe combine things that I'm doing? Maybe I can reuse compute for multiple purposes. Maybe if I switch from something like a Lambda function to something like a container, which can handle multiple processes at the same time, or multiple requests at the same time in the same process, I can get more cost savings because I'm running more requests per second out of a single process than using one process for every single request that comes into my system. There's a lot of different ways that you can look at these soft savings and how they can be included into what you do. It can be, is my team deploying faster than they used to deploy? Well, if they're deploying faster, they might be using less resources to deploy. Am I using less people to support my production environment? These are other cost savings that aren't necessarily the hard ways to do it, the tangible, like on and off switches, but they're downstream effects of things that you do in the cloud and how you realize these other savings that happen. So just to back it up with a little bit of context, talking about the cloud in 2021 and beyond, Gartner's also recognized 3 of the top trends in the cloud market. So cost optimization is driving cloud adoption. So we've heard this old story before, moving from data center to cloud and optimizing once you get in the cloud, but cost optimization in the cloud is driving adoption. And as people understand the OpEx model of the cloud more and more, you're seeing more and more companies extend their utilization in the cloud, and that's every cloud provider that you see, whether it's Azure or whether it's GCP or whether it's AWS. You see all of these clouds growing year to year, and that's because customers are getting better and better at understanding how to expand. However, they do still trip on a lot of wires along the way. And one of the wires that get tripped on is that there's an insufficient amount of cloud skills. And it's a growing market. It's a fast growing market. I know we've had cloud for a while now, but at the rate that cloud is expanding, there are a lack of skills in the marketplace for companies to hire that truly understand how to run cloud efficiently. And then lastly, cloud is becoming more and more distributed. Not only is it becoming more distributed around the world, but it's expanding its service availability everywhere. And that only makes things even more complex. What's your optimization on, in the East Coast, the West Coast? Are you getting into hyper local data centers that some of the big cloud providers are talking about? Just at reInvent, AWS announced that they're going to be doing these kind of like hyper local data centers within cities. How are you going to contain everything that you're doing in the cloud and understand what your cost optimization is between all of these distributed locations that you can run your application?
Just on that second point there, Kevin, it's interesting because, like you said, the cloud's been around a while now, and a lot of people have got a lot of knowledge about cloud. Many of the people on this call will have like infrastructure skills within the cloud, but I think because the rate at which the cloud develops, the infrastructure develops, the new services, the new techniques and solutions that are out there, it's the constant rate of learning that's kind of important, which is why there's always seems to be that insufficient amount of cloud skills, because the cloud is always changing at such a rate. What you knew maybe 6 to 12 months ago, there's new, more efficient ways of doing it today. And I think that's where we're always finding this kind of catch up with cloud skills. Would you agree with that?
I would absolutely agree. And my, kind of a personal story to go along with that is years ago, earlier in my cloud career, I was happy to have, I think it was all 3 AWS certifications. Right? And then I was like, well, maybe 3 is not good. Now I have all 5 AWS certifications. I will say that I never extended from that number, but just look at that, like the areas that you can get certified. I think I don't know the exact number anymore, but there's
I
probably
think there's 12 now.
yeah, there's up to like 12 certifications that you can get with AWS. It's hard for one person to know it all. It really depends on how your organization uses the cloud and the talent that you need. But I would say that's absolutely how fast this industry is moving and
Sure.
how fast we're adding new features. It's tough. It's tough to stay on top of it as an organization and keep hiring that talent. So very good insight. So when we go to the cloud, we kind of want to make it basic. I know I've been talking about like there's a lot of different regions, there's all different things that you can do, there's a lot of different cost models, or there's a lot of different ways for you to pay for the cloud. But I'm going to try and break it down to 3 simple cost models that you can look at least for compute. And we're gonna kind of put a box around compute for right now, because compute and storage are probably the 2 biggest spenders out of all cloud services that still exist today. We're going to focus on compute right now. And there's usually 3 different ways that you buy your compute when you go to the cloud. The first is on-demand price. That's list price. That's MSRP when you go to the car dealership. That is, you show up, you say, hey, the cloud provider says, I'm gonna charge you $1 an hour for this EC2 instance, and you go, okay, it sounds good. And you get your compute, you get an SLA, you get everything that you want to run that instance. Now, that's all and good when you go to you go and you want that one instance, but what if you want to buy in bulk, right? What if you want to say like, hey, I don't need just one instance for an hour. I need a lot of really expensive instances for multiple hours, maybe even 24 hours a day, 7 days a week, 365 days a year. Well, the cloud providers, including AWS, they have commitment options. And in AWS specifically, you have reserved instances and savings plans. So what you can do is you can commit to the cloud provider. You can say, I am going to run this instance for a full year. I'm never going to stop it. And in exchange for that commitment, I'm going to pay you these dollars every single hour of every single day for the whole year. You're going to let me pay less for that instance. But even if I don't run the instance, I still have to pay you, because that's what I'm paying for. I'm paying for that capacity every hour. But what you can do is you can save anywhere between maybe 30, 30, maybe up to 50. Sometimes in extreme cases, you get maybe a 55% savings on that EC2 instance, depending on how you buy your compute. So if you're running a lot of workloads that are very consistent, say you have a very large database, these also work for services such as RDS and Elasticsearch. If you are running services that are pretty consistent, they run all the time, all year long, commitments are a very, very good way to save money. Savings plans also add a little nuance into this, where even if you do have a little bit of scale to your workloads, savings plans will kind of blend those different EC2 options together for you. We're not going to get too deep down into that today, but there are a lot of different commitment options that you can use to lower your price. Now, the third option, which is actually the lowest cost or cheapest option, is spot capacity. And AWS is offering spot capacity in EC2. They offer it in Fargate. They offer it in a few different places. Specifically on EC2, you can get instances, that same EC2 instance that you would have bought on demand, or that same EC2 instance that you would have bought with commitment, you can get for 10 cents on the dollar, a 90% discount. Now, why do they offer this? AWS is building out capacity all the time. They need to keep excess capacity around for all of their customers. Their customers, when they come in, they'll run, spiky workloads from time to time. They need to have a lot of extra capacity just kind of lying around in the data center. And so what they do is, while this capacity, while there's available capacity of people not paying on demand prices, they sell this in a market. Years ago, the market used to be public. Now the market is kind of private to AWS, but you can still get it if you can see the use as a whole. But the price for a spot instance will actually go up and down, usually at a very significant savings, somewhere between 70 and 90%. The risky part here is that if AWS needs this capacity to sell more on demand, or needs it for customers running on demand or commitment prices, they will take this capacity away first. So there is no SLA on this compute. It will be taken from AWS at a certain point in time. And that's why for native use of Spot instances, it's usually used for batch workloads. Now, we're obviously going to get down into Spot instances a little bit more going forward, but generally speaking, when you go to the cloud, these are the three options you're presented with to buy compute.
When AWS take that resource away from you, is that, do you still get a 2-minute warning on that?
You do. You get at best, the way that it's worded, the warning is not guaranteed at 2 minutes. It is a up to 2-minute warning from AWS. And they do have mechanisms where you can watch for that warning and build a DIY solution around that.
Got you.
So that's a great segue into what the Spot by NetApp platform does and how we use those three pricing constructs that you saw in the previous slide. And instead of you having to build something DIY and figuring out how those pricing models work and how they fit best with your application, what the Spot by NetApp platform does to do that for you automatically, so you can think about other things like deploying your application and not about all the infrastructure and how you pay for it. So a little bit about Spot and where we sit. A lot of people on this call are probably very, very familiar with the concepts of continuous integration and continuous delivery. We consider ourselves as part of the continuous optimization space. And what does this mean? After your application goes through your CI/CD process and gets deployed to production, who's making sure at that point that that application scaling, operating, and running as optimized and efficiently as it can be? And that's where our platform fits in. So customers can integrate with the platform ahead of time, either through the Spot API or Terraform, CloudFormation, all the different tools that they use to deploy to the cloud. And then once your production applications are running in the cloud, we want to make sure all of those pricing constructs that we talked about before and some other scaling mechanisms that we watch, which I'll talk about in a little bit, are making sure that application is as optimized as it can be while running on this infrastructure in AWS. So our core value proposition, and everybody's core value proposition when you run to the cloud, should actually be don't pay the cloud provider any more than you have to. If you don't have to pay list prices to AWS, don't do it. It's the same compute. When I went through those three models before, it's the same EC2 instance that you're paying for in three different ways. So why not pay the lowest, cheapest price that you can? So the Spot platform does this for you. It wants to drive on-demand compute to as close to zero as possible. And how it does this is with all of the thousands of customers that we have, we're watching the spot market on AWS in every single availability zone across the entire world. And we're analyzing it and predicting when those spot markets get congested. So we can notify applications far sooner, up to 15 minutes in most cases, that a spot market is going to be saturated. And we can start moving workloads far in front of when the AWS warning would happen. Not only that, but we can tie in on-demand reserved instances and spot instances into a holistic application that can keep you available, 99%, 4 nines, 5 nines, whatever your application needs. So when we look at capacity and we talk about this scaling, what you want to think about is if you want to get this cheapest price, if you want to go out there and you want to get EC2 instances for spot prices, what you don't want to happen is the graph on the left, right? So your application is running along, your application gets a warning, or worse, you don't get the warning and your application drops out, and now you're under capacity for a certain amount of time. And then within 2 minutes, or maybe within no minutes, your application has to scale back up to that required capacity line. So that's what you want to prevent. And that's what the Spot platform is preventing automatically. Or if you do it on your own, you want to think about this. You want to be running along at the required capacity of the application. And then before that capacity goes away, or in time for you to get enough instances into your cluster that the application that keep running, you want to actually scale up. You want to go higher than the required capacity of the application, because what's going to happen here is you're going to pay very, very little to over provision your scaling group for a very short amount of time, have that application gracefully scale back down to the required capacity and continue to deliver the same SLA to your customers that you were delivering before. Furthermore, when you get down to the end of this graph, if there is no spot capacity left, you want to have a way to fall back to on demand. So when you talk about spot markets, you can choose to run your application on one spot market or many spot markets. But if those spot markets become congested, what do? And you can fall back to on-demand capacity and still look for compute pools within the cloud provider that have availability to serve your application. So this is another thing that the Spot platform will do automatically for you, so you don't have to build a DIY solution, where it will sense what markets are congested, what markets aren't, and if there aren't any markets available, it's instantly going to go out and get you on-demand capacity and run that on-demand capacity for you so your application stays available. Most important thing for any application is that it's available and adhering to its SLAs for its customers. So this is something you want to think about when you're doing cost savings in the cloud, how you also keep your application running and serving the requests that it needs to serve. So changing your pricing model is kind of changing your pricing model and how you pay for your instances and how many instances you're using are more of a hard cost savings. One of the, kind of blending the line between hard cost savings and soft cost savings is how you scale your application in general. So when you deploy your application to the cloud, are you using one type of EC2 instance? Like, for example, when I deploy an application, do you use a C4 2x large, and then you have an auto scaling group with only C4 2x larges in there? Now, what happens is that C4 2x large might somewhat meet your application demand, but as it auto scales up and down, you're probably wasting a certain amount of CPU and memory along the way. Now, if you use a heterogeneous way of scaling and you run something like a Kubernetes cluster, or you run multiple applications and containers that can sit on the same EC2 instance, you can get a lot more creative on how you scale. So as an application scales up, you can actually use a bunch of different type of instances to fulfill the requirement that the application needs. So as you scale up, you don't always have to add that 2x large instance. You might be able to add an extra large instance, or you might be able to add something from the M family or the C family or the R family. If the memory and the CPU requirements are shaped in such a way that you can more intelligently scale up and scale down, you can actually meet the curve of your applications in general for your whole cloud account much more smoothly. And so while you're using maybe the same number of instances or the same type of compute, using different sizes and different families will kind of give you this soft savings where you can get this nice smooth line of scale up and scale down and not pay the cloud provider to over provision on your scaling groups. Also, if you have a baseline of what you're running, these reserved instances or savings plans, which the Spot platform can also buy and sell on your behalf, or you can do it on your own, you can keep a baseline of reserved capacity so that if you do fall back to on demand, you're actually falling back to reserved instance prices and you're not falling back to full on demand prices. Again, understanding all of the compute in use, what your application is doing, and how consistent your compute is actually running, you can use all of these three pricing constructs to your advantage.
That's a great graphic just to drive home that point of using different sized EC2 instances to, like say, follow the curve. It really kind of makes the point clear on that slide.
Yeah, and it's something that we used in VMs a lot. We had customers deploying a lot of different sized applications to VMs, and they found out that just because of the price, you might be able to get a much larger instance for a much lower price. And so you would use different instances in that aspect. And then as Kubernetes has come into play and as containers have come into play, now you have all different shapes and sizes of applications potentially living on the same VM. And so now it's even more important. That VM, you don't necessarily know how that VM is shaped anymore. So being able to shape those VMs for the workloads that go on them is becoming even more important with containers.
Nice.
So how does Spot by NetApp do this at the end of the day? And we're going to go through our product suite real quick, and I'm going to tell you what each one does based and how it contributes to cost savings. First is Cloud Analyzer. When you come into the platform, we have a product called Cloud Analyzer that shows you the full view of what you're looking at in your cloud. Cloud Analyzer will actually look at every single service that you're using in AWS, and it will tell you how efficient you are being in any one of those areas. It'll automatically detect if you're using scaling groups, automatically detect if you're running RDS, Elasticsearch, Kubernetes, EKS. It looks at all these different places where you can save money easily. If we move on from Cloud Analyzer and we take that whole view of your cloud account and we start looking at how to take action on how to make that efficiency as close to 100% as possible, we'll start with Eco. And Eco is all about capacity planning. And this goes back to that number 2 bullet that we talked about in a previous slide, which is commitments and how you manage commitments. So we talked about you can save easily 30 to 55% just by buying one, but you got to make sure you run the compute the whole time. If you buy commitments and you don't run the compute, you're actually losing money, and you never want to do that. What Eco does is it takes all the different ways to buy commitment capacity in AWS and automatically manages it for your cloud account. So it will take into account reserved instances, savings plans, and it also takes into account the AWS secondary RI market where you can buy and sell RIs. And by putting all 3 of these together, what can happen is it can give you a portfolio of commitment options so that if your compute changes over time, you don't have to fight with the commitments that you bought previously, because Eco will automatically convert them or sell RIs back in the marketplace or buy lower cost RIs from the marketplace from someone who doesn't need them and place them in your account. So by creating a commitment portfolio on how you deal with AWS, you can drive that savings even further than you can with maybe a single savings plan or a single RI purchase. And then over on the right, we have our actual virtual machine and container optimizations in both Elastigroup and Ocean. Elastigroup and Ocean talk to the concepts that I spoke to before about VM scaling, right sizing, and Spot. So these 2 products will really focus on how those applications scale, if they're getting the right pricing model underneath. So if it's getting a Spot instance or it's getting a reserved instance or an on-demand instance, and it's going to make sure the applications running either on top of those virtual machines or those containers are running as efficiently as possible. So we're going to dive real quickly into one of the products. Kubernetes is the hottest topic of the day, so we're going to jump right into the Kubernetes offering, which is Ocean. And what the Spot platform looks at to optimize Kubernetes, whether it's EKS or standalone Kubernetes implementation, and how we look at it and how we look at the savings that can be provided at every layer. So first off, with containers, something that people forget about when they deploy is that container right sizing itself and observability on how containers are running are one of the biggest drivers to how efficient your cluster is running. So if you over provision a pod, like if a developer comes in and says, hey, I need 2 CPUs and 4 gigs of memory, and they deploy it to a Kubernetes cluster, that's going to request that amount, but it may never actually use that requested amount. So there's different mins and maxes and different settings that you can place on a pod itself, or a pod and a container itself, to right size the actual request to the cluster for the memory and CPU that it's using. So Ocean has a right sizing feature in it where you can hook your CI/CD platform into Ocean, so you can always get on your next deployment, be deploying a YAML with the right amount of CPU and the right amount of memory. To do this on your own, you want to set up your own monitoring service. You want to be able to get an aggregation of all the pods that are running, and then you want to historically store that over time, because what you don't want to do is take small amounts of that pod or that container running and make long-term decisions. You want to see how your cluster runs over time, and you want to see when things scale up and scale down, how these pods react. that is something that the platform is able to do, is able to suck in all those metrics and actually make decisions over the long haul. The second layer that we'll talk about is container-driven auto-scaling. So we have a controller that sits inside the Kubernetes cluster. And what that controller is doing is it's looking at the topology and architecture of that Kubernetes cluster and determining how the pods are scaling on the cluster. And then I'm going to go to the third layer while I talk about this, but it looks at how those containers are scaling and then ties it into the bottom layer, which is the infrastructure provisioning and pricing. So by being able to talk with the scheduler and know what the scheduler needs ahead of time, so it knows, in the next hour, I'm going to need X amount of CPU and X amount of memory that I don't have. How do you go out and then find that amount of memory and CPU out in the menu of items that AWS sells to make sure that you're getting the lowest cost option that's being brought into the cluster? So when you tie in that container driven scaling along with the infrastructure provisioning, you get into this this cycle of knowing what is being required of the cluster and then how to purchase the right infrastructure to make sure it's as efficient as possible. And that's what the Ocean controller and the platform are doing in the back end, is it's looking at all of those things I just talked about that you need to be aware of in the Kubernetes cluster, and then making sure it makes that next right decision. And that decision can be scaling up or it can be scaling down. And scaling down can be as important as scaling up, because when you scale down, you want to make sure that you don't remove VMs and you don't remove things from your cluster that are going to adversely affect the applications that are running on top of them. So when you scale down, you want to make sure that you're not damaging any replica sets that you have, any stateful containers that you might be running. There's a whole lot of logistics that go into scaling down that are just as important as scaling up. So how do we do this at the end of the day? Our customers stay committed to us because we do all of this for them. There are some DIY solutions out there. There's open sourced controllers. There are things that you can do with Grafana on your own. But when you need to take everything under your own house and you want the efficiency of bin packing, and you want the efficiency of scaling, and you want to tie that in with all the pricing models that exist in the cloud, you need to have a platform that makes these decisions for you. We do a lot of modeling and machine learning on the back end to understand the ebbs and flows of all the different markets that happen in AWS. We understand how the Kubernetes cluster runs over time and how most efficiently to bin pack. These are decisions that the platform makes that we kind of take out of the DIY hands and offer as a service. And this is why customers trust us with their production infrastructure and run large-scale applications on our platform, because we can drive all of these savings by using all the concepts that we talked about today and kind of do it automatically. It's we like to think of it as an easy button for the DevOps team. They can turn on the platform and all this stuff that they were going to think about doing on their own is just done for them at the end of the day. And they're still saving tons of money.
Easy buttons are always good in production.
Easy buttons are great. Easy buttons. We need more of them in life, I think. So real quick, we're deployed in over 50 countries worldwide. We serve enterprises, SMBs, cloud native startups. We're pretty much in every single vertical. Anybody who uses cloud can use the Spot platform and take advantage of what we have to offer. And with that, I will turn it over to the Q&A.
Brilliant. Thanks very much for that, Kevin. So as you've been going through your presentation, we've had a few questions come in. So firstly, will Spot take care of scaling up and down, or do we need to use auto scaling?
So the Spot itself, I guess it depends on it depends. So on Elastic Group, Spot does all of the scaling. It scales all of the VMs for you. So you never have to scale a VM. With Elastic Group, it will automatically scale based on any metrics. In Kubernetes, there's two levels of scaling that I talked about before. So there's the container level scaling and the VM scaling. Our customers never have to scale a VM. Ocean works hand in hand with the HPA of Kubernetes. So the same horizontal pod autoscaler that you would use with a replica set in Kubernetes, you would still use that to scale your pods. What the Spot platform is going to do is it's going to understand what the HPA needs, and it's going to make sure it has the infrastructure for that HPA to be successful.
Okay, excellent. There's another one here relating to auto scaling. If I use EC2 auto scaling, will it be able to automatically allocate and prioritize any of my unused saving plans and RIs before spinning up new Spot instances?
With the Spot platform, absolutely. So we always make sure, so cost savings is paramount to everything that we do on our platform. So whenever we spin up an instance, we see what is the best scenario for our customer. How's the customer going to save the most money? So when we make that decision, we're going to see if there's any unused reserved instance capacity or any unused savings plan capacity. And if there is, we're going to use that capacity up before we go and get Spot instances, because actually we could go spin up a bunch of Spot instances. You could be wasting a bunch of money on your RIs and your savings plans. So we do make that distinction for you, and we'll always make sure you're 100% utilized on your RIs and your savings plans before we go to Spot.
Okay, excellent. Next question, is Ocean Observability capable of displaying usage of each tenant in Kubernetes?
Of each tenant. So the observability in Kubernetes, we break everything down by the Kubernetes construct. So you can see anything from a namespace level layer down to the container, and that includes your pods, your CRDs, anything that you're running on there. So depending on how your organization is set up, everybody carves up Kubernetes in a bit of a different way. But if you carve things up by namespaces, we can break up cost savings and chargeback and showback and all that information by namespace. We can also go down to the container level to actually tell you what resources a particular container is using. So yeah, a lot of our customers use Kubernetes in different ways. Sometimes different departments have different clusters. They can see all of their clusters in one space. Some of our customers use one big cluster, and they use a lot of different namespaces or other constructs within Kubernetes to carve things up. So I hope that answers the question. If not, ask again, and I'll try and answer it better.
Another question here relating to security. Does Spot also optimize for using AWS security measures such as Inspector, Guard Duty, WAF, etc.?
Yeah, so Ocean works with everything that you can use on AWS. So we don't replace any of the services that you would normally use in AWS. So like we fit right in. So if you're using EKS, we work with EKS, and anything you can use with EKS, we can run with. You don't have to change your Kubernetes management plane to use us. We fit in fairly nicely alongside every service that AWS has to offer.
Excellent. May I use the Spot platform with applications that require you to keep the same external IP address?
Absolutely. So again, when you use the Spot platform, and one of the things maybe I didn't explain well enough in the beginning is we operate inside your account. So you're not handing off, like we're not creating a new front door for you at the end of the day. What we do is we go into your current AWS account and we sit alongside everything that you can do in AWS today, and we manage that compute through a shared role. So it's not like we're running in a different account or we've obfuscated your AWS options from you. You run your same account with your same permissions and all the same technology that you run. We just make sure that we scale and operate your clusters at scale in the most efficient way. So if you're using dedicated IPs through some sort of load balancer or other service in AWS, there's many different ways that you can actually get that nowadays. A global load balancer, for instance, you can still use those services, and they will all still work with what the Spot platform is doing inside your account.
Sure. Excellent. Thank you, Kevin. We've got a couple more questions here. How is Spot different from Cloud Health and other cloud platforms that offer cloud management?
So it's a great question. And we actually work alongside a Cloud Health and Cloud Checker quite well. If you already have those tools today, those tools are very good at giving you reports and identifying where to save. the Spot platform actually does the savings. And in Cloud Health and Cloud Checker, they'll recommend that you might use Spot instances somewhere. They might recommend a set of RIs to buy. They'll also give you a lot of other breakdowns and reports that you can use. The Spot platform, however, is going to do all of that for you. So instead of it recommending that you use Spot instances, you're going to hand over, the keys to allow the Spot platform to manage that scaling group for you. And when we manage that scaling group, we'll start making those decisions so you don't have to. So there's no lag time between recommending a cost savings option and using it.
It's just
the day you start using the Spot platform is you instantly start saving money. Yeah.
Brilliant. And how is the pricing managed, and how is it for non-commercial projects?
Pricing model is we have a free tier. So I'll start with that. You can come on and, anything under less than 20 instances of management, we don't charge for. So we have a freemium option. You can come on and use the platform to your heart's content. If you do run a larger group, we charge by savings. So it's a success-based model. We charge a percentage of what we save or what we run compared to on-demand prices that you would pay. So we go out, we get a spot price for a 90% discount. We're going to take 28% of that savings list price. If you have a very, very large or enterprise, hundreds or thousands of nodes or a large implementation, we also have enterprise options and commitment options that you can pay for also.
Okay, thank you. Are you able to display the cost based on labels and annotations instead of namespaces?
Cost-based annotation. So based on labels, so we can identify labels, and we can identify based on labels. So I don't know if that's where the question was getting at, but that's what I'll answer.
Okay. We've got one here relating to Elasticsearch clusters. Can the Spot platform be used to optimize those?
Sorry, what was that? Sorry, you broke up a little bit.
Can the Spot? That's all right, no worries. Can the Spot platform be used to optimize an Elasticsearch cluster?
So for an Elasticsearch cluster, what we can do is we can absolutely manage the reserved commitments on an Elasticsearch cluster. We have customers do this all the time. Elasticsearch is no different than RDS or even DynamoDB. AWS sells commitment options for all of those platforms, and we can actively manage those commitment options for any of those services.
Excellent. We've got two more questions, then I think we've answered everything. I heard AWS now provides a signal when a Spot instance is at risk of interruption. Does this now make it safe to use Spot instances for production workloads?
Right. So I wouldn't say that the signal alone makes anything safe for production workloads. There's a lot to go into how you react to that signal. The signal is also not guaranteed. It's a up to 2-minute signal. It's the same signal that you would have. They've actually always sent a signal to the EC2 instance. Now they've opened that up on their event bridge as well. So it's less about getting that signal. It's more about what you do with it and if there's enough time to react to it. Our goal is to always beat the signal, is to get you into a better capacity pool or get you into a better instance before you ever receive that signal from AWS.
Excellent. And the final one, do you think AWS will deprecate reserved instances?
We don't see any signs of that right now. We know there's a big push on savings plans. We have customers who buy new reserved instances every single day. I don't see that going away. There are still options where you get much better savings with a reserved instance than you get with the savings plans. Savings plans are easier to buy, but you get less savings with them. If you know what you're doing, you can save a lot more by buying reserved instances. And as long as customers keep doing that, I don't see AWS taking them out of the purchase options.
Brilliant. Well, I think you've answered all the questions there for us. So is there any more slides, or is that the last one?
I believe that's the last, I think okay. There's there is a wrap-up slide. Thank you.
Oh, okay, brilliant.
Always a thank you slide.
Excellent. Excellent. Thank you very much. So yes, again, thank you all for joining us today, and a special thanks to you, Kevin. It was a great presentation. It was really interesting to hear about the platform offered by Spot and how it can be used to manage your costs and optimize them in the cloud, and again for the overview of the Ocean product as well. I've certainly got plenty to think about from this webinar, and I hope all of the attendees have too. We've had some great questions coming as well, so thank you to everyone for your participation on that. Just as a quick reminder, everyone will receive the recording via email as soon as it's available, and don't forget to check out our other webinars as well, which you can find on our website at cloudacademy.com. So any final words from you, Kevin, before we go?
No, just thank you again. Really appreciate it. And absolutely reach out social media anywhere if you have questions about cost savings or the product, and look forward to doing it again sometime.
Definitely. Thanks very much, Kevin. Thanks, everyone, and goodbye.